A pleasant day to everyone. I am Engine Cadet Caliguia and I'm here to present about the ship's steam system. So here we can see a representation of a simple boiler, and on board the ship, the heart of the steam system comes from the main boiler. So in order to produce steam on board the ship, we incorporate the principle of evaporation and condensation, wherein the feed water is being heated up through combustion or through exhaust gas, and the steam produced is being used for various heating purposes such as various machineries, fuel oil tanks, and many more. Therefore, in relation to my presentation, I will elaborate in depth the overall steam system on board the ship. I will give the system components, the proper tracing, and also I will also incorporate the troubleshooting, repair, and maintenance of the boiler. And not only that, but also the proper operation of firing the boiler. So what is the importance of knowing the ship's steam system? Well, first, we will be able to understand the different systems embedded such as the steam generation, the boiler combustion, the steam condenser, and other consumers such as the turbo generators. Second, we will be able to trace the ship's steam system. And third, different components that make up the steam system. Fourth is the proper operation or firing of the boilers. And lastly, the troubleshooting, maintenance, and repair. So, steam is being used and utilized in various or several ways. So, here's number 1. Heating for bunker tanks, storage tanks, fuel oil tanks, settlings and servings tanks, sludge tanks, and waste oil tanks. Second, it is used for heating the main engine and auxiliary engine, so the preheater. Third is the operation of purifier. Fourth is for accommodation purposes. And fifth, for turbo generators. And sixth, inert gas system. Most especially, it is used for tanker vessels. We will now dwell to the system components. First is the hot well or cascade tank. Second, boiler feed water pumps. Third, oil-fired boilers that runs in diesel and fuel oil. Fourth, an HFO and diesel oil pumps. Fifth, exhaust gas boiler that runs through the main engine exhaust gas. Sixth, condenser, it is heat exchanger that converts steam into condensate liquid through the medium of seawater. 7. A steam turbine. So this extracts the thermal energy from the superheated steam and convert into electricity or energy or work. And lastly, the inspection tank, wherein all used steam that is converted into condensate liquid will go into this tank for inspection before it goes back to the feed water or cascade tank. For the operation of the steam system, we go first in the proper operation or proper firing of the boiler. So here I will show you the step-by-step procedure using the simulator. So here's the steam generation plant that we can see in the simulator. For the first step, we must check the parameters of all the level, the pressure, the temperature of the boiler. And also we do the bottom blowdown and the surface blowdown. And third, we replenish the feed water in the steam drum. And third, we set up the water level controller if it is in good running condition. And also we line up all the valves. So this is what the procedure is telling us. We filled up the steam drum and also we align the valves and pumps before firing the boiler. Next is the boiler combustion. So this is where the burners are being operated. For the next procedure, it is important that we purge the boiler in order to remove the unburned gases inside the furnace that may result to explosion if left neglected. So the longer the better, and much safer, so around 3 minutes or 5 minutes that you do the purging. And while purging, we ensure the atomizing air are lined up, and also the temperature for HFO preheater is set to 85 degrees so that the fuel will become less viscous. So it is important that we line up first all the valves from HFO and DO service tanks in order to recirculate the fuel in the boiler combustion. And next, once purging is done, this is where the air-fuel ratio comes into action to control the airflow and oil flow and to avoid alarms. So before we start the burners 1 and 2, we reset the trips because it will not start if trips are indicated. So once trips are reset, we can now switch on the burners 1 and 2 simultaneously, we can see a small flame coming from a pilot burner, and then it will turn into a bigger flame, meaning the main burner is already running. So we can observe them through the sight glass of the boiler. We can see here that all controllers are switched to automatic, and the pressure in the boiler is 7 bar, and the temperature of the HFO is above 85 degrees Celsius, meaning that it is ready for the changeover procedure from HFO to DO. So once the pressure is reached and also the temperature of HFO is okay, then changeover can now begin by switching the three-way valve from DO to HFO. Then we will switch off the DO pump, and also there's another three-way valve. So from atomizing air, we will now switch to atomizing steam. So once the boiler reached the desired pressure and also the temperature, it is now the time that we can open the main steam valve in order to supply steam to various heating services, such as the heaters in the purifier, in the main preheater in the main engine, and also the engines, to the fuel oil tanks, service tanks, storage tanks, and so on and so forth. So aside from the principle of evaporation and condensation in the boiler, I would also like to incorporate the Rankine cycle that is happening inside the turbine. So what happens is that the superheated steam being generated by the boiler is being used by the turbine, and this superheated steam is being expands through the series of turbines and also generated the electricity through its output shaft. So for a turbo generator, from the thermal energy coming from the superheated steam of the boiler, it drives the turbine blades, and for the output coming from the shaft, it gives electricity or work. So again, we can see here in the diagram that it has a main steam valve going to the turbo generator because it also consumes superheated steam needed in order to produce electricity. And after the used steam goes to the turbo generator, it will go to a condenser where the cooling medium is seawater to convert steam into condensate liquid. So to summarize, here's a simple diagram. From hot well, the boiler feed water pump will take suction of feed water and deliver it to oil-fired boiler in order to produce steam. The steam is then used for main and auxiliary steam system. On the other hand, if ship is en route, it is fitted with exhaust gas boiler water circulation pump that delivers feed water to exhaust gas boiler, and the steam produced will then be used as heating medium for oil-fired boiler, thus reducing the amount of fuel oil consumption. Lastly, excess steam and used steam goes back to condenser to convert it back to liquid and settle to hot well or cascade tank. So here we differentiated between exhaust gas boiler and an oil-fired boiler, and one of the consideration here is the state or the condition of the ship, whether it is underway, maneuvering, or anchorage. So here's the overview of some of the troubles and alarms associated with boilers. So for the maintenance of the ship's steam system, always refer to the planned maintenance system and read always the manual before conducting maintenance. Some of the important checks are the following for the proper firing of the boiler. Most important here is the two safety valves that must be calibrated. So for daily operation, here are some work and check procedures that have to be considered every day. We also have weekly routine checks. So here are the following checks. And also monthly routine checks for our boiler. And lastly, the inspection of furnace must be taken into consideration. So here are the following inspection. And lastly, the boiler water treatment and testing. So this is very vital or crucial in maintaining the boiler. Prevent contaminants and most especially prevents corrosion. That's all. Thank you so much.